times time.
Initial velocity, v initial plus
acceleration times time.
This is the formula that you use.
Yeah.
Okay, let's write down the formula. You said for 3.2.2, you said v final, it will be v initial plus a delta t. So now what you're going to do, v final, I think we already have the initial velocity. It was 2.5, né?
Yeah.
And we chose to take down as positive. So where is this going? It's going down, né?
Yes.
Okay, so it was, the velocity was given as 2.5 plus the acceleration is also going down, which is positive 9.8. Delta t is the one that we calculated. So this tells us that if delta t was wrong, we were going to lose marks on this one. And you said, what was your answer?
22.88.
88 meters per second.
Meters per second.
So you also have to know that this is going downwards. Okay, thank you very much. That's very correct. Now, they said that calculate the height on point Y above the ground. The height on point Y. They want us to find the height, this height. I'm not sure if you can see that, or maybe we can highlight that with a different color. This is the height that they want us to find. So, to find that height, you know what I'm going to do first? Let's talk about this. We have, which formula can we use? Maybe we can start with that. V final, we have V final at that point. So I'm going to do data on my answer sheet. I'm going to do data because if I have data, I'll know which formula to use. Data, I have the V final, which was 22.88 meters per second. Okay, this is what I had. So now, if I'm trying to do that, if we can go back to the question, it will be highly impossible for us to only work with this part. Can you see that? Because we don't have more information. So what we can do is that we can also include this one. I'm going to use A because I know that here my V initial is what? My V initial was 2.5. So now can you see that if I include my initial velocity, I know that I can calculate the distance from this point to that point. You understand that?
Yeah.
So if we calculate the distance from that point to that point, that's when we can, for the final answer, that's when we can subtract the 5.2. You understand?
Yeah.
Okay, let's do that. We said V final, V initial, it was 2.5 meters per second. And now we need to find a formula that has V final, V initial, acceleration. Yeah, if we choose a formula that we can use, we're going to get that the best formula to use is Vf squared. It's equals to V initial squared plus 2a delta y. Yeah? So now this one, we calculated it was 22.88. We equate this to initial of 2.5, which is squared plus 2, 9.8 delta y. We need to isolate delta y. So the best thing that we can do is to write this as 22.88. We need to subtract that 2.5 squared. Therefore, on this side, we'll be left with 2 into 9.8 delta 1. The answer you get, you need to divide it by what? 2 into 9.8. You need to divide this whole thing by the 2 into 9.8. Therefore, you'll know what is delta y. This is the maximum height for ball A. So what do you get when you punch that on the calculator?
I get
What is your answer?
0.85.
0.85. That's delta y.
Yeah.
Is this making sense? Oh, we forgot the squared here. You know why I'm surprised? Because
Oh, yeah.
remember that the height between ball A and ball B is 5.2. So when you get an answer that is less than that, you see now?
Yeah, I thought I put it wrong on the calculator. Great.
Okay.
It's 26.39.
26.39, eh?
Yeah.
So now if it's 26.39, so that was the maximum height. You understand? That was the maximum height of ball A. So to find from this point, maybe we can highlight that again so that we can be on the same page. So the maximum height from this point to that point, it is 26.48. But we are looking for this point to that point. So we need to say 26, we minus the 5.2. You understand that part, ne?
Yeah.
So it will be delta y. It's equal to 26.39 minus, what are we minusing? The 5.2. The answer that you get is your delta y. It's your final answer.
I got 21.19 meters.
21.19 meter. Nice. Yeah, now, and that's it from this question. We are done answering question 3.2.3. Can you see that?
Yeah.
Okay, great.